the TWT team, I heartily welcome Raj. And before we begin, I request everyone to post your questions in the chat box. Uh, I guess,
Yes,
I guess Raj, the baton is yours now.
yes, Raj.
Thank you so much, Puneet, and thank you so much, Ishan, and the rest of the TWT Bangalore team, and everyone else who's joined me today to, listen to me talk about some of my experiences and some of my insights about AR and VR. I'm as enthusiastic as you to kind of share my perspective and some information about AR and VR. So before I actually move on to the slides and whatever the agenda which we're going to take up today, I just wanted to, kind of say that the session is not purely for technical writers itself. Even if there are people in this audience today who are UX writers or somebody who is just interested in knowing about AR and VR, you can benefit from it as well. Because I will be talking a little bit about right from the origins of the technology to where it is now, what you can expect in the next couple of years, to the tools which you can eventually use and things like that. So it's not specifically completely focused on technical writers, although we will be talking a little more extensively about certain use cases which you can implement back in your organizations. But it is a general sessions which should give you a pretty good idea of what is technology and what you can expect in the next couple of years. So I'll go ahead and share my screen. As Isan mentioned, if you have any questions, please feel free to put it in the Dropbox and we'll pick it up as and when we can. I hope my screen is visible to all.
Yes, Raj.
Okay, fantastic. So we'll just quickly talk about what we want to discuss today. I want to talk a little bit about what's been happening in the news because some of there might be some incidents you might have heard of where augmented and virtual reality has been mentioned off and on in the press. There was a recent kind of a viral thing which is floating around where teacher in Kerala was using this to teach kids in school, and the IIT Bombay did their online convocation using virtual reality because of the entire COVID situation, and a lot more organizations and companies all over the world are slowly adapting some of these technologies to collaborate a lot more with people. So I want to talk a little bit about that and talk to you about why this field has suddenly become exciting. One of the things is that these technologies are not something that just came up a couple of years ago. For example, like a mobile technology or mobile other things. AR and VR have been around for quite a few decades actually. But one of the reasons why it's suddenly in the forefront and there's a lot of interest kindled around these technologies now is because there's a lot of key developments that have taken place in the last 4 to 5 years that have really sort of catapulted this into the next level. And that's something which I want to explore as well. I want to talk to you about how do you make virtual reality and augmented reality apps? What are some of the popular tools that are used in the market, both paid as well as free? And if you want to put together a team in your organization to create an AR app, whether for a product or for a technical documentation purposes, what kind of skill sets you would require? I would like to talk about that as well. I want to talk to you about the fundamentals of the technology itself. How does it work? What if I want to, let's say, view something in augmented reality? What kind of equipment or hardware will I require? In case of virtual reality, what kind of investment I might need to put in? That's something which we'll talk about as well. We'll look at some interesting documentation use cases, which you can directly go ahead and explore if that is something which your organization is doing currently. We'll look at design tips. This is more in terms of the user experience, usability, and the user journey of how somebody uses this technology to interact with it. And finally, I'll probably walk you through a few demos. Some demos are one or two apps which I've made and kind of recorded them to show it. And I'll also show one or two examples from the industry, so you can get a kind of a more wholesome perspective of where exactly this is, and you will be able to relate it in context to your particular role. So, talking about what's happening in the news, I just have a bunch of popular snippets over here. So, as you can see, it's all over the place across the whole spectrum. So, right from things like the entertainment industry, uh, manufacturing, aviation, education, healthcare, you name it. Every field has found some or the other interesting use case for AR and VR, and are actually taking it to the next level and implementing it. So you'll see a lot more adaptation of these technologies in the coming a few years. It's already begun, but you'll see it a lot more become a lot more commonplace as the years go by. So some of the things which actually kind of kick-started this, as I was mentioning earlier, is some of the things that happened in the last couple of years. So one of the things, the great things that happened is that mobile technology suddenly picked up with a lot more speed. There's a lot more improvements in hardware. Things became a lot more faster, and a lot more complex technologies which were previously found in, let's say, personal computers could now be found on cell phones. And this kind of opened up the Pandora's box for AR and VR. One of the first things which started was AR Kit by Apple. And that's one of the SDKs, one of the development kits which developers can use to create augmented reality experiences for iOS devices. Immediately along with that, Google started AR Core in 2017. AR Core and AR Kit are going very strong right now, and Google also has something called AR Foundation, which they came up, I think, a couple of months ago, which is also a more stronger, more robust platform to develop AR VR experiences. It makes it a lot more simpler with less coding intervention to develop these experiences. And the Unity game engine. So if you ever played a mobile game, you would probably see this small logo called Unity or made with Unity. So Unity is a game engine which is used to make computer games. But then it has so much of great functionality to work with 3D objects and animation and models, which is again the core of augmented and virtual reality. It's a very immersive experience. So Unity allows you to do that, to seamlessly integrate a lot of different kind of things, right? From audio to video to stereoscopic motion to a lot of other things, which makes it very ideal for development of AR and VR apps. And you have other things like other SDKs, which are like extra plugins, which can be used within Unity to easily prototype and build AR and VR experiences. One of them is Vuforia. You have others like Wikitude, which also you can go ahead and do that. And the reason why the tool is called Unity is because it unifies a lot of platforms. So I write code or I develop once in Unity, I can export it to Android, I can export it to iOS, I can export it to a HoloLens device or to a PlayStation console. I just code once and I can export it to any number of platforms. So it gives me that amount of flexibility, and it reduces so much of burden on the developer, and it saves so much of cost as well. So Unity is a great tool. At the end of the session, I'll also show a very quick demo of how Unity looks like as well, so you have an idea of what it is. One of the other developments was Microsoft came out with something called HoloLens. It's a sort of a goggles that you wear, which has inbuilt display. You can see a lot of things, you can interact with a lot of objects, it provides a lot of information. So very interesting gadget, which kind of set in motion a lot of things for the AR and VR industry. And the market is just expected to grow and grow. And if you see the final logo here for something called Magic Leap, this is a very interesting company. It's still very hush hush, but there's a lot of billions of dollars in funding that's already gone in, which claims to, kind of project images directly into the retina of your eye. And it's supposed to be revolutionary and a real game changer, but we still don't know too much about it. But it is something which a lot of people in the industry are excited for. So first, what I want to talk to you about is I want to give a little bit of background, historical background, and a little bit of technological background. First, we'll talk a little bit about augmented reality. We'll talk a little bit about virtual reality, and then we'll talk about which is the best suited for us as technical communicators. So starting with augmented reality, the concept itself is not very new, as you can see from this illustration. L. Frank Baum, who also authored the Wonderful Wizard of Oz, the children's book, wrote this very short story in which this boy finds a pair of spectacles lying on the ground, and these are enchanted magical spectacles. And whenever he wears them, it gives him some sort of special powers. So one of the powers it gives him is that whenever he looks at people around him, it automatically starts projecting the a letter of the alphabet above people's heads, which others cannot see. Only he can see when he's wearing those goggles. So, for example, if a person is good, so you'll see the letter G floating on top of their head. If a person is evil, maybe the letter E would come on top of the head. So even though there is others cannot see it, only through these goggles he's able to see that. And that was one of the very a very primal primitive concept. And later on, of course, Thomas Caudle, who did a lot of pioneering work with AR tech at Boeing, he kind of coined the term augmented reality. Augmented from the dictionary simply means supplementing reality, which means you're not replacing reality, but you're adding another dimension and an extra dimension. In this case, a digital layer onto what you see around you. Basically, what it does is that it turns the environment around you by placing virtual objects between the device you're using and the real world. So, for example, I'm using my phone. So between my phone and let's say the wall in front of me, there is a 3D object or a computer generated object or an image which is inserted in between. And that is exactly what augmented reality is. So it can be in the form of a 3D model, it could be an animation, it could be a video, or it could be an information overlay like a call out. Let's say I point my phone at a pair of speakers and I have a call out which pops up which says, hey, this is the volume control and this is for the bass and this for the where you plug in the mic or something like that. So that kind of information overlay also can be placed on top of real world objects. And you can also use audio, not just through a visual display. You can also use audio to implement augmented reality. So you can think of the possibilities when it comes to things like accessibility, which we technical writers keep talking about off and on. And there are a lot of companies who have been doing very pioneering work. IKEA was one of the first companies which at least interested me in augmented reality in 2014, 2015. So IKEA, as you know, is the furniture manufacturer, right? You order, let's say, a sofa from IKEA, they'll send it to you in 25 boxes. And you're supposed to look at a manual and follow the instructions to build your piece of furniture. What they did was created an augmented reality app which could be downloaded to your phone, and you simply point at a piece of furniture and a 3D display would pop up which would tell you how to assemble that particular piece. So that entire huge manual is not required anymore. So you can see the kind of implications that could have in terms of cost, in terms of how easy it is for people to kind of do things. And of course, the most popular examples of late, Pokemon Go, which was kind of a craze a couple of years ago, and very recently, Google also has these 3D animals where on your phone you can see a tiger popping up in your living room. So it's nothing but a 3D model of a tiger, which is placed there using augmented reality. So what it exactly does, or the little bit of background of how it works, is augmented reality, virtual reality, or sometimes you might have heard the phrase mixed reality as well, which kind of combines both of them, are all a subset of the bigger boss, that's artificial intelligence. So under AI, one of the things is something called CV or computer vision. I'm sure all of you would have experienced computer vision without kind of really knowing what it is. So let me give you some examples. Sometimes on your phone, when you turn on your camera and you point at a bunch of people, let's say you're taking a group picture, sometimes you'll have these small boxes coming up next to people's faces, right? It kind of immediately recognizes that this is a human being and this is the face of that human being. So that's what computer vision does. It recognizes objects, it recognizes distances, it recognizes surfaces, grounds, walls, vertical, horizontal surfaces, using a technology called SLAM, this simultaneous localization and mapping. So it just looks at something and uses your devices, accelerometer and gyroscope to kind of build like a digital map of everything around you. So if you're sitting right now in your room and in front of you there's a laptop, it will be able to kind of figure out, okay, the laptop is placed at a distance of 2 feet and there's a wall behind you at a distance of 3 feet, and the corners of your room are diagonally 3 feet or 5 feet away from you. It uses this information to decide where to place that augmented reality 3D object between you and your field of vision. So if you see in the third snapshot there, you see a newspaper with a Nokia, the 3D model of a Nokia phone popping up. So basically what computer vision is doing in this case is it's recognizing first of all the flat surface of the table, and then it's finding out the distance from your eye or the device, in which case is the camera of your phone, and it's identifying x and y coordinate of where to place or position that objects so that it's now exactly on top of that Nokia ad that you see there. So that's in a way basically how it works. Of course, it goes a lot more deeper in terms of natural feature tracking or optical natural language processing and text recognition and a lot of machine learning and deep learning related tech. But the main idea is central is computer vision. So that's the main backbone of how augmented reality works. There are two primary ways in which one can experience augmented reality. One is through a mobile device, which could be a tablet, which could be a phone. So basically, your camera will act as your eye. And in this example, as you see, you're looking at through your camera, phone camera, at let's say a coffee cup sitting on a table. So, but in between currently there's nothing. But if you implement augmented reality, you will be able to place some sort of a 3D object between the phone camera and the coffee cup. And in this case, in the screenshot or example, it is nothing but like a call out or overlay, which simply has lines coming out which say, okay, this is like this brand of coffee or some nutritional information or some other stuff. The image on the right is for an example of the HoloLens, which I mentioned earlier from Microsoft, which is nothing but HMD. HMD is a head-mounted device, which is very common for virtual reality. So in order to use this kind of display, you need to wear one of these. And there's a lot of stuff which is built into it. There's a kind of like a microcomputer and a very powerful lens, and all your other gyroscope and other thing is built into this lens, through which you can directly look at objects around you, but it also presents some sort of an information overlay on the screen itself, while you can also see objects nearby. Two very key things, which again we will touch upon this when we talk about how we can use it in our documentation perspective, is how do you implement augmented reality? There are two methods. One is called a marker-based method, and the other one is, of course, a marker-less or without a marker. So a marker-based method simply means that in order to invoke an augmented reality experience, you scan something with your phone. So it's something similar to a QR code. The concept is similar. QR code also you scan through your phone, and it might take you to a website, it might take you to a payment gateway, whatever, right? But in the case of augmented reality, it will pop up a 3D model or a video or an information overlay whenever it is scanned. And this has to be, it could be a printed thing, it could be something on the screen. But the whole idea is that it needs to be pointed at some particular object, which is called a marker, which invokes an augmented reality experience. So this could be any image of your choice, as long as it has good contrast. Because let's say, for example, you're just using a plain paragraph of text as a marker, it will make a terrible marker because there's nothing unique about it. So one piece of text could look the same as any other piece of text. But if you have a lot of color contrast and a lot of other things, it will be unique, so that if you have 10 different things which you want to show, your program will be able to easily pick out what data to associate with which particular marker. So make sure that whenever markers are chosen, there is good contrast. You can choose images, but again, like I said, they should not be very similar. For example, two pictures of the same car or the same color to show two different augmented reality experiences is a very terrible choice. But maybe one of a red car and one of a yellow car will still help my camera identify that, hey, there are two different colors. So for this color A, this information is displayed. For color B, some other information is displayed. So that's something about the whole thing about the marker, that whenever something is pointed, a 3D model or some information comes up which the user can interact with or provides additional information about whatever they're scanning. It could be something about the features of a car, or it could be in terms of, let's say you have a new server that your company is manufacturing, and somebody points at the user manual or the quick start guide. A 3D model of the server pops up in front of you, and you can rotate it in 3D, and it shows you where are the connection ports, which are the different nodes, and what do the different LED lights mean, and things of that sort. Some things, there are some situations where we would probably not really want to use something with a marker. One thing is that, as I mentioned, you need to point your phone at the marker, which means that if I move the phone away or the marker away, the entire 3D experience will collapse. So they have to be in, the camera needs to be looking at that marker at all time in order for it to remain active. Of course, I will demo this when I show you some videos, so you get an idea of what I mean by moving away the marker and things of that sort. And also another thing is whenever augmented reality is, you're also seeing objects around you, not just the 3D model, but you can also see, let's say, the table or the wall or anything next to you as well. But since if you're keeping a marker in front of you, your hand which is holding the marker or the table which is holding the marker is covering some of the real world space, which could not be a very good idea in case, let's say, you want to use it in a factory to train, let's say, employees, and people are working with heavy machinery. So you don't want them to be obscured by some object which could lead to safety related concerns. So there are certain situations where it is not really an effective choice for implementation. On the other hand, the second method, markerless, is something like hands-free. You don't have to worry about having something to scan. You just point your camera directly at the object and it will start overlaying information on top of the object. So this is again based on computer vision technology and something called feature tracking and object recognition. So it looks at something and you already coded that information into your program and it identifies that, hey, okay, this particular object is now lined in to my site, which means now this information has to be projected onto that, and it begins doing that. You can see in this example, somebody's working with a piece of some sort of factory machinery over here. So similarly, it could be anything, let's say your laptop, or it could be, there's a great use case. I also seen this in action is for aircraft maintenance manuals. I mean, there are a lot of people in our industry who are working in the aerospace documentation space, and this is a fantastic use case where it's a very immersive and a very interactive way of providing information to people. And like I said, this does not require a marker. It uses the real world as the marker. And once it identifies the object, even if you move your phone a little bit away this side and that side, nothing is going to happen. You can still track the object to quite a distance. And it has massive application in a lot of industries as healthcare, especially oil and gas, training for people on ships and barges, and manufacturing spaces. There's a lot of traction picking up there. Bosch, one of the companies in Bangalore, has a AR wing who does very interesting things, right from training people on AR VR to implementing a lot of these kind of apps and technologies for different industries across India and across the world. So why are we talking about AR so much is that something interesting about AR is that it's become very cheap to implement, at least in terms of the device angle. If you're thinking about implementing AR in the 90s or early 2000s, you would need to have a very powerful computer to kind of just get things started. But then whatever were there on those computers at the time are now all there in your pocket. You have your touch screen, you have motion sensors, you have GPS, you have your gyroscope, accelerometers, you have fantastic display, you have great sound. All everything that makes a great visual experience is now already there in a very fast device in your pocket. And that's why there is suddenly this boost that yes, mobile devices and tablets can now usher in a new era of AR in the market. And also the greatest thing about mobile phones is their battery power. So you don't have to worry about always having them plugged into a power port. For example, like a virtual reality, some of the virtual reality devices need to be connected to a very fast computer. That computer in turn needs to be plugged into uh, some sort of a electrical socket, which means that the experience is great, but it's stationary. Whereas in augmented reality, the entire experience can be portable. For example, Pokemon Go, you could go and catch Pokemon over here or in Japan, it doesn't matter because that experience can be portable with these devices. So that's one of the things which makes it also interesting for us as technical communicators because everybody has access to cell phones now, and the newer cell phones come built with a lot more features which are more conducive for augmented reality experiences. So here it's just a quick snapshot of some of the real world applications of augmented reality. As you can see, the first image on the top left, it's a marker based experience. You can see a person scanning something and a 3D model is popping up between him and that object. Similarly, some of the other places you'll see implementation of a marker-less method where you just point at the object and it shows you something. And in the middle image, you'll see somebody wearing a HoloLens. which is again imprinting 3D information on top of the object, but using that particular lens device. Of course, the applications here are plenty, right from music to gaming to education to healthcare, plenty of stuff. So this is a little bit of an overview on augmented reality. If you have any questions so far on augmented reality or whatever I've spoken about, please free to pop them into the chat box. I will pick them up when we do the Q&A. As we move on to a little bit about virtual reality. Now we spoke about augmented reality. I want to touch upon a little bit about virtual reality, which is a far more denser field. It's a lot more complicated, and there's a lot more factors involved when designing experiences with virtual reality. One thing is the main difference. If someone asks you, "Hey, what's the difference between AR and VR?" Because most of the time there's a misconception that both are the same, and, because they keep getting mentioned in the same breath, right? People keep saying, "Yeah, AR, VR, AR, VR." So most people think, "Hey, it's probably the same thing," but they're vastly different. And they're distinguished chiefly by the level of immersion, which means that how much of information that you're presenting to a user is computer generated. In augmented reality, it could be 1%, it could be 99%, which means that you will still be able to see real world objects around you and interact with them. You will not be completely blocked off, but some percentage of the experience will be digitally generated. For example, in front of you and the wall, I'm placing a small 3D model of a coffee cup. So that maybe takes up 10% of your space. So 10% of it is augmented in that space. So if you can see this example here of Iron Man and the Matrix from back in 99, the experience is over here. You can see some real world objects, but in the case of virtual reality, it completely blocks off the light because you're wearing a headset, and whatever you see through the headset is what is your perceived reality, what your senses perceive as reality at that particular point in time. You simply cannot see any objects around you. You're completely blinded. So that's the chief difference between augmented and virtual reality. Here's another kind of a schematic which will give you a little more uh, deeper understanding of what it is. So as you can see, it's basically there's no experience with the real world in terms of virtual reality. You are completely dependent on what the device is showing you, which makes it all the more important for the experience to be more lifelike. And in case of augmented reality, you can see the stuff around you, but also you're seeing some sort of digital information projected to you. So virtual reality is again being discussed tons of times in literature. So in one of these earliest books by Stanley Weinbaum, he talks about a kind of spectacles. When somebody wears them, they can actually feel the sense of touch and smell, etc. Probably if some of you might have gone to these malls and they have a 7D kind of goggles thing, right? Where you wear that, you can feel a splash of water sometimes, or you feel kind of the force feedback or motion, things of that nature. So that's all nothing but virtual reality tech. A little bit of history in a couple of slides. I'm just kind of tracing back where it began, where it's going to. It's been around, like I said, from the 60s and 70s. They've been like kind of things which were made purely for entertainment purposes. Then there was Ivan Sutherland, who's kind of known as the father of VR tech, who did a lot of pioneering work in developing a lot of these kind of goggles and force feedback and using hand controlled haptic controllers to move objects around, and their applications in different kind of aerospace and training industries and things of that nature. And NASA, of course, had a very dedicated AR/VR lab right from the 70s and 80s, which is quite well funded at the time, who used a lot of advanced optics and advanced computing power available at the time to kind of take it to the next level and see where they could go. Of course, the 80s were again a great boom because of gaming and also a lot of pop culture, which embraced a lot of futuristic technology stuff like Star Wars, and there were also companies like Nintendo who built a lot of kind of gloves and goggles, which users can just plug in into their game stations and kind of view things in more like 3D and stuff like that. So that was again something which was very very important to the development of VR to where we are today. If you look at what happened beyond 2000s, excuse me, Oculus Rift kind of came and changed the game. Oculus Rift was one of the first devices which kind of gave a very immersive 3D virtual reality experience to the user. It was bought over by Facebook in 2014, and right now they have a lot of flavors. There are a lot of other companies who are doing very interesting stuff. There's HTC, who has a headset called HTC Vive. There are a lot of other companies who are going to be coming up with a lot of VR headsets, which will become cheaper eventually. And if you see here, you'll also see things like the Google Cardboard, which is nothing but a small piece of cardboard with kind of lenses in it, which you can use, you can put in your phone there and you can experience virtual reality. I will of course have one or two lying around with me right now. After this session, I'll quickly show them to you as well. So in order to experience VR, you can start with the cheapest. You can start with a Google Cardboard right from 300 Indian rupees. Two, you could go up to Oculus Rift, which is 70,000 to 80,000 rupees, or the HoloLens, which is 1 lakh and upwards. It depends on how immersive you want your AR VR experiences to be, and based on that, you can choose your choice of hardware device and go ahead with that. Of course, and the interesting thing now, what's happening is uh, a lot of these companies are making headsets which are a lot more cheaper. For example, if you look at Oculus Rift and Vive, these are not completely standalone headsets. They need to be connected into a very fast computer with a very fast graphics card, at least 6 to 8 GB of video graphics memory, 16 GB of RAM, those kind of very hardcore specs. But of late, if you look at the previous slide, the very first device called Oculus Go. So this costs around 12,000 Indian rupees, or about $200, which is a standalone VR headset. So you can still experience a lot of cool VR gaming and a lot of other entertainment stuff, but without spending big bucks as its brother, the Rift or the Quest series. So you'll see this becoming a cheaper and cheaper as the years go by, and that's also very exciting for people who want to develop experiences for it. So virtual reality, again, to quickly give you a primer of how this works, is it mimics how the human body perceives the world around it. What I mean by that is, in the human body, there's an inner ear vestibular system, or the IVS, what they call it, which is responsible for balance in the human body. So if you ever tried closing your eyes, both your eyes, and tried taking a step, you feel a little bit of disorientation, right? Because one of your senses that you use to make sense of the world around you, which are your eyes, your vision, is not in use at the time. Similarly, with virtual reality, since you're projecting a completely 3D world to the person, it is very important that it imitates the real world. What I mean by that is the human eye, if you look straight, there's something called a field of vision, which means if I'm sitting straight, maybe about 120 degrees to the right and left, I can see everything around me, but I cannot see what's behind me. Even to the complete right of me, I might be able to just see a kind of a blurry thing of what's happening, but only unless I turn around, that section of the real world won't be clear to me. The same works with virtual reality as well. When you're creating a 3D world or a 3D object which the user can explore, you need to make sure that it emulates the real world. So, for example, if the person is wearing the headset and turning from left to right, the scene should move at the same number of frames per second that the human eye or the human mind or the human body is generally used to. If it goes too fast or too slow, you get something called a simulator sickness, or you start feeling nauseous. People might start vomiting, and it's also called latency. And this is one of the biggest challenges of virtual reality technology, that to get that thing right, to make sure that people don't, because one of the things which happens with virtual reality is that if somebody wears the headset for too long, they'll start feeling sick, because there's only so much you can imitate the real world. But for some experiences, it is great, but not always. And VR headsets come with a lot of other gadgets. You have hand controllers, you have room sensors, basically four things around the room which will track your position all the time. And you can do different things in the headset. For example, I'm wearing a headset, and let's say the scene around me is of a beach. So I turn everywhere around, I see a beautiful beach around me. So I can do different things. I can just lift my head up, down, and I can see up, I can see down, I can turn left, I can turn right. Or I can do what they call a more translation tree movement, which is I can even walk 2 steps ahead walk two steps behind, walk two steps to the right or left, and explore more of the surroundings around me. So it depends on the level of immersion for which the device is built. In this image, if you see, it's the person is wearing a headset with two hand controllers and two room sensors, which is tracking his movement all the time around that blue color mat. Which means anytime by mistake, if he tries to step out of that map, he'll get an alert on his screen saying that please step back because you're going out of bounds and it's not safe. And it's always plugged into a very fast computer, which is powering this entire experience because the person is wearing these goggles with two lenses, and for each lens, the entire experience is generated separately. So that's why it takes a lot of computing power to create VR experiences. So here are some of the common tools. Again, as you can see, Unity is one of the most popular tools. So there's a lot of stuff you can do with Unity and other game engines through which you can create virtual reality tools. And on the right, I have mentioned certain 3D modeling software. So I'm not sure how many of you have experience with 3D modeling, but things like Maya and Cinema 4D and Houdini, these are very popular with the film industry. So if you look at any Pixar movie or any animated film or any sort of CGI in your whatever Marvel universe or anything, a lot of that stuff is made using either one of these or a combination of these software. And once you create any 3D and any objects, you can bring it into your virtual reality world, and you can use it. And the right on top, I've listed Blender. So this is something which is completely free. It's open source, and you can do equally beautiful thing. Of course, it's not that does not have those many workflows as Maya or Houdini because those are very expensive, cost lakhs of rupees. Whereas Blender is free, it's open source, so you can still make a beautiful animated 3D model in Blender at absolutely no charge. Oh, and I also forgot to mention Unity is completely free of charge as well. So you have all the features of Unity unlocked for you to try out and do whatever you want. Only if you publish something to the App Store and that makes or crosses a certain amount of money, will Unity ask you to pay for a registered package. Otherwise, the personal edition, anybody can download it for free and you can do fantastic stuff just with the free version of it. So, illustrating a few real world applications, I'll give you a few seconds to take a quick look at this to see how widespread the use of AR and VR is across different kinds of industries around the world, right from colleges to gaming to healthcare, and even for technical communication. So if you look at things like for higher education, or if you have products where say safety training, for example, you have your companies building some sort of mechanical products and you want to either train new users or you have already have something in place and you want to provide some sort of your technical documentation information within that 3D space, that is where technical writers can play a very important and key role in the future, because there are a lot of companies who will keep building hundreds of different kinds of VR stuff, but sometimes people who are using it might be using it for the first time, so they will need instructions too, right? Not only in a very technical writer context, but in general, you put on the headset and turn it on, people should know what to do with it. So that's where technical writers can be people who can guide users in their journey on how to use any particular app, whether it's a sports app or gaming app, doesn't matter. Now coming to the most interesting thing and what I think most of us are looking forward to is for tech writers. Now, we talked about AR, we talked about VR, what's been happening, how it kind of generally works, what kind of devices, etc., etc. So for tech writers, it's so interesting because everybody has smartphones and tablets, most of them at least, and it's a great method of implementing and deploying AR experiences. VR, of course, they will need to have one of those headsets. There's a new technology called Web VR, where you can present VR web experiences without a headset within the web browser. That's a slightly kind of new concept, but eventually it will pick up. But for VR, you will generally need a headset, and that could be expensive. Again, not everybody might be interested in buying one or using it, but mobile phones, they are around everywhere, so it's you can be sure that yes, the amount of adoption for your documentation that you create in AR will be a lot more. Why would AR, or why should you use AR in technical communication? Is first of all, people are always using mobile phones. You can leverage a lot of processing power of your computer, and you have a device camera, and it will supplement your existing documentation to a very large extent, especially the biggest use cases is for hardware products. It could be like your company is making laptops, cameras, storage systems, networking products, machinery. Anytime a hardware product is involved, even if it's a very small thing as a computer mouse, it can still have a great impact using augmented reality for guiding users. You can show them videos, they can just scan the mouse or its user manual and get all the information they need without accessing your documentation, which you already have in, let's say, a PDF or a HTML format on your support portal. Software as well, there are some use cases, but again, as you can imagine, there are some instances where it doesn't really make sense for me to use it in a software perspective. If I want somebody to type in a username and password on a field, I will just tell him in the user manual, hey, go over here, type in the username and password, and you're done. Go to the next screen. There's no point in me spending so much to give that information in the form of augmented reality. But maybe in certain very complex software scenarios, you can have the screen of the software itself as a marker. So if somebody scans it with their phone, it will immediately bring up a video or give some specific information about what they need to do on that screen, or any dependencies or configuration information, setup, etc. etc. So what kind of information can you use AR for tech writing? Ideally, it's great if it's for task-oriented content where you're talking about procedures, database procedures, or any kind of procedures where somebody has to perform a series of steps which are not generally very straightforward. That's a great use case. If you want to educate somebody about a new concept and give them, kind of good information about how something works. Let's say, for example, how does a Wi-Fi router work? I can present that information more realistically, more effectively, which will guarantee a lot more retention in the person using augmented reality or virtual reality. Also, it's great in case, if you're using it for geolocation content. For example, Pokemon Go. Initially, I showed you one screen where it showed the Gatwick Airport app. For example, let's say you have very old parents or grandparents who are probably traveling to the airport for the first time to come visit you in the UK or the US, and it's their first time at an airport, and it's obviously very bewildering for them to get through the gates and find the terminal and things like that, right? So they can just turn on this app and it will start pointing arrows as to where to go, and that is based on geolocation, because you're providing an endpoint saying, hey, take me there, and it keeps pointing that on the real world right in front of them. It's great again for user guides, for a lot of, like I said, hardware and networking products, or any sort of hardware product wherever a physical, tangible object is involved. AR will always make a great use case for documentation. Again, based on the marker and markerless methods, here are just some examples. Of course, this list is not extensive of when you can use marker and when is it preferred to use markerless. At least this is based out of my experience so far. That ideally use something with a marker if it's like a user guide or a quick start guide or something like that, and go for a markerless if you want to, let's say, tell somebody how to install something or disassemble a piece of physical equipment, or train somebody new onto some particular piece of hardware, those kind of situations. So this is one beautiful example. Hyundai has been rolling this out, I think, since 2016, 2017. Haven't really seen it in India yet, but it's definitely there in across all models in North America and Europe. This, as you can tell, it's a markerless app, user manual app, through which you can get to know all about your new car. You just point at any section of the car and it will tell you what's going on there. I have a video which kind of demos this beautifully. I will play this as soon as we wind up here. But that this is one of the very good use cases of how you could use this within your documentation context. So to deploy it, coming to the part where we talk about how do you make an AR app, how much will it cost? I don't know any programming, or I'm not very good with tech. I just know some basics of tech writing. Can I still be able to make it? Yes, you can. So that's one of the things which I wanted to kind of spend some time talking about, is that I wanted to demystify this notion that these are very complex technologies which will require a lot of detailed knowledge of computer vision, AI, machine learning, deep learning. Of course, it's great if you already know that stuff. But even then, there are a lot of these packages and libraries and a lot of tools which already has that stuff built into it. So you just kind of more or less drag and drop in most cases, and you have the functionality without kind of reinventing the wheel. So typically to have like a good AR app, or at least to prototype a decent app for your organization, you can do it for free. You don't have to spend any kind of extra money, at least for at the prototype stage. Later on, if you want to buy a full version of whatever 3D model you are using, or let's say you want to host it onto an app store, because eventually you'll have to host it onto one of the app stores, that might cost you extra money. But to just create a prototype, you can do a lot of fantastic stuff to convince your management absolutely free of charge. You don't have to spend anything. The kind of typical team which you need to put together will of course require somebody with a little bit of programming knowledge, again not very detailed knowledge, a little bit of basic stuff about C sharp, how to do some basic to advanced level C sharp stuff. If you have a UI UX designer on board, that's fantastic, because the way you design AR VR experiences is vastly different from how you would design, let's say, a wireframe for a mobile phone app, or for a cloud app, or for an on-premise app, because there's a lot more interaction and immersion going on. So the way somebody approaches that is different. So a UI UX person will be great to have. Third thing is, because AR and VR relies heavily on visual information, 3D models, 3D environments, animation, it is always great to have somebody with 3D modeling skills. Somebody knows how to make 3D models or animation and visual design, graphic design, that kind of knowledge. Of course, most of our companies have graphic design folks on board. So somebody with a little bit of 3D modeling skill would be great. Also, you need not fear, because there are a lot of online stores where you can buy 3D models for $2, right from free to thousands of dollars. You can buy the 3D model. Let's say I want to buy the 3D model of a train. I can spend 6 months sitting and making it myself, or I can spend $200 and buy the 3D model and insert it into, or import it into Unity and start creating my experiences right out there without having to invest too much. Also, you have a lot of other platforms like Blip AR, 3D QR, which I'll also quickly show you, where you don't really even need to know that basic programming knowledge. It's like a drag and drop kind of a interface. So I go to that screen, it'll ask me, okay, hey, what do you want to create? You want to create a AR experience or a VR? You choose AR. Let's say I want a 3D model of a mobile phone. I pick it up from somewhere, drop it onto my stage there, add whatever text I want, publish, and I can already prototype it immediately. So there are all these kind of aspects that are involved. Primarily, if you can dig into Unity, it gives you a lot more flexibility. It's a lot more customization is possible with that. So that is fantastic to learn. But even otherwise, just to prototype, just to show it to people, promote a particular idea, it's great. At least when I started it, it really helped me. I learned a little bit of Unity, but also later on, it made sense if, let's say, somebody is coming down, let's say my client, and I want to showcase something with AR VR. Rather than just talking to them about it, I would quickly make something in Blip AR or something, just to quickly show to them how it would eventually look like. And if they're interested, they can then put in the money, allocate resources, programmers, etc., and build a final product to be rolled out to the customers. Finally, in terms of the design, like I said, the design that you do for an AR VR app is vastly different from other kind of computer interfaces. But again, some things are very common, because people are already used to your mobile phones. They are very used to things like, okay, you pinch and you hold out to zoom and unzoom. Those kind of gestures, use those even within your app as well. There are different modes on your phone. You hold the phone straight, it's portrait mode, and you tilt it around, it's landscape. So if you want to show a bigger screen, a clearer image or environment, you can use that those modes which are built into your phone as well. Make sure that the app is doesn't have too much of stuff on the screen. It might be very intimidating to new users. Keep the screen as clutter free as possible. If you want to show 6 different steps of something, make 6 different screens rather than trying to club everything into one screen, which sometimes might first of all crash the experience. Sometimes it might also happen that people are using different devices or different screen sizes, so it might not be great on some devices, it might be great on some others which you have tested it on. So again, make sure that you try and keep it as simple as possible, show as few items on the screen as possible. And again, make the user feel safe. This is more in context with virtual reality, because the person is not exposed to whatever is outside of the virtual world. So make sure that you have on-screen audio prompts or video prompts, which kind of tell them that okay, you're right now over here, don't worry, or take or just move to your right to do this, or always press this button at any time to exit out of the experience if somebody's feeling nauseous. That kind of information can also be presented. So one quick thing about 3D modeling, since I kept talking about 3D modeling, and 3D modeling is the core of any augmented or virtual reality experience. These are the tools which we talked about. And one last thing which I wanted to mention here is about polygon counts. Now, for example, if you want to create a website that loads quickly, but also has images, I'm sure that you would choose something like a .png format. Why? Because the size of the image is very small, so it will load very quickly, right? And the quality is also pretty decent. The same kind of concept works with 3D models as well. As you can see in the image here, there's a 3D model of a phone. But again, the clarity of a 3D model or the way it looks is different depending on something called polygon count. In for a good picture, you take a camera out of a DR, you take a picture of a DSLR camera, and you directly use the raw format. It looks fantastic because the number of megapixels or pixels that are crammed per inch is a lot, and that gives it that great depth and the real life quality. But once the image is compressed into a JPEG or PNG, it will slightly diminish the quality because it's reducing the number of pixels. But still, the image is viewable. It's kind of good, but it's not as great as that. But it's great for a website where you want it to load quickly. Similarly, if I'm creating a 3D model of a car with very good texture, very high quality layering, it will probably be more than 2 or 3 GB, which is not feasible for somebody to download on a phone all the time. But if I compress it, but still make it kind of look good, maybe the size would come down to something like 30 or 40 MB, which is great, which is still something which uses less memory and also loads faster on the person's device. So those are again something which you might want to consider whenever you're designing for AR and VR. Okay, so I think I'm done with my presentation here, and I wanted to take some time and do we still have time? Yes, I think we have about 5 to 10 minutes left.
Raj, there are a
Yeah,
couple of questions here,
Yeah,
which
I'll quickly take a look at them and
yeah. So the first question, what Ashish has posted, I think that's already covered in your slides. Ashish, do you still want Raj to answer that, or because in one of his slides he had already covered that?
yeah, because Raj, I found these are open source, but are these for free? Euphoria or something? Because I don't think beyond certain limit, I think there is a fee for it. So have you ever found out something which is a freemium? It's actually the gist of my question.
completely free. Again, depends on the model in which you want to use the product, Ashish. So, in
Okay.
case even Vuforia, you can still use it for your commercial purposes, but as long as it does not exceed a few number of scans. For example, I create something beautiful and my customers are using it through a marker, let's say, but it will have something like only 1,000 scans. So
Okay.
after somebody scans the 1,001th time, you
Okay.
start paying a per view kind of a thing to Viforia. So that's the kind of model which Viforia is currently operating on. Wikitude has something similar. So most of them will make you, I mean, let you do a lot of commercial stuff with it, which you can go ahead and publish to your app stores and give it out to your customers. But beyond a certain level of scalability is where the kicker will come in, that you will have to pay something to continue using it on a larger scale.
Got it. Got it. And one more question was that what is the output file that we consume in this AR VR of I mean that output file of 3D model, because after conversion, like is it in
Mm-hmm,
some
mm-hmm.
step
Right.
or yeah.
So basically, it's the same format which is accepted or compatible with Unity. So Unity has compatible with a lot of formats. Some of the popular ones are .ca, .cae, .fbx, GLTF. There are some
Okay.
popular industry standard extensions for 3D models. So you
Yeah.
can look that up with Unity. So whatever Unity accepts, can be
Okay.
used for building AR and VR.
Oh, nice, nice. That was very helpful, Raj Kiran, because I was using earlier UDL and other forms, but
Mhm.
didn't find that
Yeah, so
like
UDL and things, what happens is the texturing, everything goes a little choppy and haywire.
correct.
But with Unity, the great part is even if you have like a very bare bones model, you can bring it into Unity, add more textures, add more, elements and materials to it to make it a lot more good looking.
Yeah, thanks, Raj Karan, and I look forward to connect with you after this session and then plan something around it. Okay.
Sure, Ashish, certainly.
All right, Raj. So the next question is by Anirban Datta. He asks how AR can be beneficial for SOPs.
I'm just looking at the question SOP for
Yeah.
data center outages where the engineer needs to run scripts to fix the outage. Okay. SOPs for building a new data center where civil engineer needs to follow one document for everything. Okay. So in this, again, you can use the marker less approach, Anirban.
Okay.
Because in case you already have a data center and you already have some sort of physical hardware installed there, it's a lot more easier for somebody to just scan that particular device. Each data center is unique, right? Somebody might be using, let's say, a Cisco so and so networking switch or so and so something else. So you teach your basically you train your AR or VR app to kind of recognize that when that is being scanned. Or another thing which you can do is whenever the person scans that, it might probably give them some sort of safety instructions that is to do with AR. With VR, like you mentioned about the civil engineer part, you can create an app which is compatible with a VR headset, which the engineer can kind of wear and maybe sit for about half an hour, and it kind of walks him through how to do it in a very simulated environment before he does the real thing in the real world.
Mm-hmm.
So that is one way to approach it, and probably a reference for this would be you can look up something called building information modeling, or is popularly called BIM. So that's an industry which is used who builds large construction projects like barges, bridges, and huge buildings and flyovers and things like that, which involves a lot of people who make 3D models, right from your civil engineers to electrical engineers. So it has a lot of different kind of people involved there. And currently, there's a lot of interesting stuff for which the BIM industry is doing with AR and VR, so that people can collaborate from different locations and view 3D models together and check if it's structurally sound. A lot of that kind of interesting stuff.
Mm-hmm. Okay, okay. Okay, so got it. So, like recently, I have worked on a document. So it's a very large document. So,
Hmm.
and actually, to be frank, so I am very new to this concept. So I have zero knowledge about AR VR. So this is the first session or first something I'm learning about it. So just I just trying to correlate with my scenarios where I
It's
can implement and suggest.
definitely feasible, Anirban. So probably one of the things which I'll share with Raghavendra or Puneet after the session. Of course, if you will be able to view the recording and maybe download the PPT, but I'll also put together one or two other PDF files which has some good links where you can go learn more about AR/VR, take up
Hmm.
courses, or explore a lot of videos and stuff like that. So which if somebody wants to pursue it a little more deeply, as you seem or Ashish seemed interested in, you could use that as kind of like a baseline to go ahead.
Okay, okay. Yeah, thanks for your answer. So, and what about the another scenario? So it's for data center, suppose there's a outage. So
Mhm.
our engine, I used to prepare a lot of SOPs, like thousand of SOPs are there. So they used to
Mhm.
follow the SOPs according to the situation.
Mhm.
So and to run the script and check
Mhm.
in the backend. So in this scenario, uh, can
Uh,
you suggest something that can be
what I would
shared?
suggest, Anirban, in this situation would be because see, in those scenarios, for example, I've worked in one situation where again there are like 100 different things a person can do, or a situation that might arise in a certain field, but
Hmm.
probably not every one of them requires documentation in the form of AR/VR.
Hmm, hmm,
Right?
hmm.
It could become very
Yeah.
complex. It could become very cumbersome. It could be very, very expensive. So I would
Hmm,
probably think maybe pick up the top five or top three, which
hmm,
are
hmm,
very mission critical kind of thing. And maybe that information you can code it in the form of AR, VR, and the rest you can of course supplement it with your existing documentation. So the main idea is
Right.
that don't throw out your existing documentation booklets, because that
Hmm.
will never go out of style. People will still use it, people will still need it, people still want it. And so many times you're legally bound to give some paper documentation too, right? We cannot
Yes.
completely do away with that. But try and see if you can supplement your existing documentation with something like this, which will make it a lot more easier for customers to do stuff. The whole endpoint of providing documentation is that, hey, the customers getting the job done without any trouble, without contacting support or without breaking his or her head. And if we can do
Hmm.
that in a more immersive and interactive way, let's do that. So that's the whole end game behind talking about AR VR.
Okay. Okay. Yeah. Yeah. Thank
Okay.
you. Thanks a lot.
Sure, Anirban.
Thanks, Raj. Raj, we have one more question from Vinita.
Sure. Won't AR VR give a false sense of security, especially dealing with machinery and Yes, it does, Vinita. In fact, that's one of the challenges, like I mentioned, that it is not meant for them to be 100%. For example, if I train somebody on AR, VR how to, let's say, operate a lathe machine, which is used for a cutting tool, used for shaping, let's say, iron or steel or something like that. The whole idea is that I won't make him use it with AR or VR and tell him, hey, immediately go ahead and start using it. I expect you to be production ready. That is a big no-no, and that is a scary proposition too. The whole idea of AR VR is to kind of at least prepare them a little bit to what they can expect in the real world. If in my training module, probably there'll be one place where I might say, hey, make sure that you turn on these and check that these light indicators are on before you turn on the machine. Maybe that is something which will give them some knowledge which they don't have to go to the production floor and learn all over again. So those kind of things they can already be kind of a little prepared for before they actually operate the machinery. And of course, you can train them a little bit on how to operate it, but again, it is not recommended. So when we are creating training modules, we need to be very specific that this is a simulation and it can get real scary out there and it can be completely different. For example, if I'm training somebody on how to use VR on a ship, in a simulation is completely different, right? Because I'm not there exposed to the real world and the real elements. But out there in the real world, there could be a storm, there could be a fire, there could be anything. The whole idea is that if I can prepare them a little bit about what they can expect, and if there are some kind of checklists or guidelines I can already prepare them for to before they actually go out and handle the real deal, that would definitely not only increase the level of safety, and it also save the company a lot of cost in overall training. Does that kind of answer your question, Navinita?
Yes, it does. And the only thing is that I feel that the tech writer's role becomes even more augmented here because we have to spell out clearly that this is working in the shadows and the real world is, I mean,
Yes,
very, very lot more
absolutely,
dynamic.
absolutely.
Right.
So, as
Thank
I
you
was
very
mentioning
much.
mentioning earlier, the main role of a tech writer over here is not to sit and do the coding or do anything, is to guide the user. And I'm not sure how many of you have heard of the term microcopy. So where we're not sitting and writing paragraphs and paragraphs of text together, but I'm just writing one or two lines saying that, hey, make sure that this is clicked or ensure that this is done. So that kind of instructions will need to be provided by the tech writer to be used within the app so that the user can be guided without any mishaps or without any sort of issues. Yeah. Is AR VR only for hardware, or it can be used for software as well, Malik, but the applications are a little less right now because as you can see in the software, there's some things which are more simpler to do how we are doing currently, right? Through a how-to video or through our standard documentation set. But in the future, there could be at least one implementation where I've seen is especially certain software which is used for analytics or for some sort of simulating a lot of complex data, big data and things like that, where two, three people can view like a large 3D graph by wearing augmented reality headset at two different locations of the world and can analyze different parts of the data just by touching it and see gain a lot of insights and examples from it. So again, that's in a very infantile stage at the moment, but that is definitely one possibility where it could be used for software. Okay.
Yep. I see no more questions, Raj.
Okay, I think I'll quickly move on to the demos.
Awesome.
Ishan, there is one thing, right, that from Malik that is taken, right?
Yeah, I just covered the Malik's question.
Yes, yes.
Okay, thank you. Sorry.
Yeah, okay, okay. Let me just quickly turn on my video here. So as I was mentioning, this is a Google Cardboard. So as you can see, it's just a flimsy piece of cardboard. So around 300 or 400, it has a lens over here. If I want to use this, I'll basically download a VR app on my phone, and I'll place my phone inside this, and I can just close it like this. So my phone is now inside this, and I can just do this to experience AR and I mean the a virtual reality experience. It's the cheapest VR headset you can buy. In case some of you are interested, I urge you to just go to. In fact, the Google website itself has links where you can buy it from right from 300 to 400 up until 1000 to 2000 something. And it's fun if you have kids at home or if you just want to play around with VR. There's a lot of cool apps you can download for free from the Google Play Store. Other than that, I have another headset. This is slightly more sturdy and comes with a better strap which I can wear around my head. And this also kind of has a lot of a better lens over here through which I can experience AR and VR. I don't have unfortunately the Oculus Rift or anything, but it's something similar. It's a lot more bulkier. It has a lot more processing thing built into it, and it usually comes with hand controllers. So if you see anytime in a mall or something where you can play games, try it out. It's a lot of fun to try that out. Okay, so I'll quickly share some demo videos here. So the first video I want to share is, let me see if you can see my screen. Yeah, so first I want to share the Hyundai car app video, and I'm just muting these because there's not much to really, but I just wanted to kind of give you an idea of, since you heard me going on and on about so much of stuff from the last hour, to see some of these things in action to give you a real context of how cool this is. So I'm just going to uh, go here. So this is a markerless Hyundai app. You can just choose which part of the car you want to look at, and it will start overlaying digital information on top of the real world as callouts, and you can get more information or animated display of what to do. So this is the exterior, and I'm just moving on to the interior of the car, so you can also get things about how do I use this, let's say, infotainment system. So I can scan that and it'll take me directly to YouTube, where it's giving me a video of how to go ahead and set it up or do something, that kind of information. So all this information is overlaid directly onto the screen. So this is one example. This is another use case which kind of something similar I had worked on a couple of years as well. It's a very simple premise. So basically, if you buy a new laptop and if you want to know where different things are or how things are done, you can just scan directly the laptop itself. Again, this is a marker-less method. I'm just scanning the real-world object. It's recognizing that object. You can see the white lines there, which means the software is identifying where it is, and now it's overlaying digital information around it. And by selecting each one of those, probably will give me more information. So this is where a technical writer's role will come in, where you provide information, whether a concept or a task-based information, which the user can make use of. Okay, so this is one, and I wanted to show you virtual reality. So this is more in context with, I think, Vinita had this question, right, about how safe is it to train somebody. So this is an example of somebody is wearing a virtual reality headset. So the one he's wearing is called HTC Vive, and this is what he's seeing in his headset. And you see those white markers, or if he wants to move forward, he just looks at one point and clicks there, and he moves to that part of the virtual world. So it's something like playing a 3D video game, but instead you are feeling it a lot more immersive. So you can navigate to different parts, get familiarized with the, let's say if you're working on a ship. So even before you actually step foot on the ship, you already know where different things are, where the captain's cabin is, where the engine room is, and that's the hand controller, which will let you interact with objects like doors and handles and things like that. So this is an example of a VR or typical VR experience. Last two things I wanted to quickly show you is one is a marker-based method. This is just a fun app which I had developed for just for fun, my kids and stuff like that. But it gives you an idea. So basically, what you see here is a marker. When it's scanned, it brings up animated solar system, which will give you more information and stuff. So I have a small slow down button. If you press on that, it will slow down the rotation of the planet so you can see it more clearly. Tapping on each, or of course I haven't implemented it in this version. Tapping on it will give you information about the planet, how many miles is it from the sun or whatever, something educational which somebody can make use of. So this is an example of a marker-based method. So if you see, the main sun is always positioned on that central piece of paper. If I were to take off that piece of paper, the entire thing would go away and I would just see whatever is there around me. So I have an example of that as well. I recorded that last night because since I cannot show you over here on the camera how it works. So this is an example of a marker which I'm going to use. So when I scan this now with Unity, the 3D model is going to come up. So you can still see me, you can still see around me, but you can still see the 3D object. But as I keep moving that, even that will keep moving along with me. If I move it away completely, it completely goes away. So that's the disadvantage of sometimes using a marker. And finally, an example of a markerless app. So this is nothing but like a small science project. So in this, I'm not scanning a marker, but I'm just pointing it to the floor so that it identifies where the floor is. And now I can move it around, place it anywhere, and I can examine it more closely. Okay, and last, I think we have about 2 to 3 minutes. I wanted to quickly show you how Unity looks like. So this is how the software Unity looks like, which has a lot of options to do a lot of things for AR and VR. So that same 3D solar system model that you saw, this is how it looked like within Unity. So these are nothing but 3D models of the different planets that I got from a different site. This is the image of my marker that I've placed here. And just by clicking this and adding a little bit of code, I can make the planet spin or move. So I'm just going to quickly show you the code snippet as well. So all it took me was just these many lines of code to make sure that the planets are moving or revolving around. So this is basically written in C sharp. Again, you don't have to worry too much if you know somebody who's a little bit good at programming, or you can always get a lot of custom scripts from the Unity documentation site, which can use to perform a lot of these kind of tasks. So Unity is a great tool to learn. I will share, of course, resources where you can learn Unity even for free, and practice a lot of stuff. It's even if you whether you do anything in tech writing or not, it's a great tool to learn and a lot of fun. You can build small games for mobiles and things like that with Unity. And lastly, I wanted to share those platforms. So if you are not too comfortable building with Unity because it requires coding and stuff like that, these are ready to use tools. Of course, you need to pay for them. Some demos you can download and use the trial version. But there's a site called 3D QR. It's a German site. You can use 3D QR to build fantastic thing for AR and VR and stuff like that. You can try it out, sign up for the trial version, look up their documentation, and you can try it out. Blip AR is another app where you can build great augmented and virtual reality demos and prototypes as well, which you can also use, just to try it out if you don't really want to go all the way with Unity and learn coding and learn the software and stuff like that. So these are very good tools to play around and have fun. So that pretty much sums up what I had to share today, folks. I hope the information was a little bit helpful, or at least help you get some idea of what this AR/VR tech is and where it's going, and how, in the context of technical writing, you could use that in the future. I will, like I said, share a PDF with useful links and a bunch of other information, and I'll also share my email address in that. So please feel free to write to me if you have any questions, anything I can help you with. If you would like to collaborate on something fun, I'm always open to it. So over to the TWT team. Thank you all so much.